Hello and welcome to the review day for the confidence interval topic. Not going to be as exciting as our normal review day. In case you were wondering what the game would have been, this unit usually happens during the March Madness basketball tournament. So as a result, it's usually basketball themed. And what I have is this game called Coconuts that has these little plastic monkeys that kind of serve as catapults, and you're trying to shoot coconuts into a basket. So that's what we would have done. Unfortunately, we can't really do that. So maybe after each question, you should just go outside and shoot a basket, or you got a trash can. You could throw something in a trash can, but sorry, that's the best we can do. All right, so let's take a look at these questions. So you want to estimate the mean SAT score for a population of students with a 90% confidence interval. Assume that the population standard deviation is 100. If you want the margin of error to be no more than 10, you will need a minimum sample size of approximately what? All right, so this is one of those find how many questions. So we need our formula, which is margin of error equals Z star, and then our standard deviation formula. And for this problem, we're going to be using standard deviation divided by the square root of n. How do I know it's this formula and not our PQ over n formula? It's basically what the question gives you. All right, if the question is giving you a standard deviation, you're probably going to be using this formula. If the problem gives you a percentage, you're probably using the other formula. So you kind of just have to read the question and figure it out from there. All right, so the margin of error, the problem tells us it wants it to be no more than 10. So we're going to plug that in here. All right, Z star is where we use inverse norm. So that's going to be inverse norm of 0.05. Standard deviation, the problem told us was 100. And then we're solving for the square root of n. All right, so again, inverse norm you're just going to do on your calculator. You're going to go to the distribution menu and type in 5% there. And that's going to give you 1.64. So we've got 10 equals 1.64 times 100 over the square root of n. All right. So you can multiply both sides by the square root of n. You're going to end up with 10 square root of n equals 1.64 times 100. I'm just actually going to do that out right now because it's so easy. So that's just going to give us 164. We're going to divide both sides by 10. The square root of n is going to equal 16.4. Then we have to square both sides to get rid of the radical. All right, and when we do that, we get n equals 268.96. So that's going to round up, and we're going to need a sample size of 269 people. And again, we always round up with these because if you round it down, technically your margin of error would be a little larger than you want it to be. So no matter what the decimal is, we round up on these. All right. Next one. An SRS of 50 students at a large middle school are asked, do you have a television in your bedroom? 28 of the students responded yes. If p hat the proportion of students who answered yes, what is the standard error, standard deviation of p hat? So this is just a formula this is just a question making sure that you know your formula. And again, that's just the square root of p q over n. And in this one, it would technically be p hat and q hat. All right, and then it's just plugging those in there. So the only thing that makes this one a little trickier is they don't directly give you P. They tell you that 28 of the 50 responded yes. So 28 out of 50 is going to be 0.56. All right, so then we can plug that into our formula. P is going to be 0.56, and if P is 0.56, that means Q has to be 0.44, because those always add up to 1. And then our sample size was 50 from the problem. All right, so then it's just a matter of plugging those numbers into your calculator, working them out, and getting your final answer. And for this one, you should get 0.0702. 0.0702. All right, so that would be our standard error. All right, let's take a look at the next one. A 95% confidence interval for P, the proportion of all shoppers at a large grocery store who purchase cookies was found to be 0.236 to 0.282. The point estimate and margin of error for this interval are, that should be of, all right, margin of error for this interval are. So remember, to get a confidence interval, it's the point estimator plus or minus the margin of error. So to find the point estimator, it's just going to be the middle of those two values. So if we add them together and divide by 2 to find the middle, so 0.236 plus 0.282 divided by 2, the middle of these, so we can think of this as the middle of our interval is 0.259, so that would be our point estimator. And then our margin of error is just how far is it from this to either this side or this side. So our margin of error would be, we could just do 0.282 minus the 0.259, and we get 0.023. All right, so that would give us the point estimator and then the margin of error. Again, this is just always in the middle, and then this is how far we're going above or below what we have there. All right, let's take a look at the next sheet. All right, researchers are studying yield of a crop in 2 locations. The researchers plan to construct a 90% confidence interval for the mean yield at each of the 2 locations. Assuming the conditions for constructing confidence intervals are met, what is the probability that at least one of the constructed intervals will capture the true mean yield at its location? And then my hint there is think binomial. All right, so if we think about this, 90% confidence means that when we start the process, there's a 90% chance we're going to end up with an interval that contains the true mean. So this is saying, what is the probability that at least one of those intervals will capture the true mean? All right, well, if we're doing 2, here are the options. Either 0 of them contain the mean, 1 of them contains the mean, or 2 of them contain the mean. All right. Now, there's 2 ways you could have 1 of them contain the mean. It could either be the first one or the second one. All right. So what we're going to do is we're going to do the old sort of binomial distribution that we did a couple units ago. And we're going to say 1 minus binomial PDF when we have 2 trials, because we're creating 2 intervals. The odds of getting the true mean are 0.9. And we want to know what are the odds that we don't get it at all. And the reason we're saying what are the odds we don't get it at all is because if we don't get it at all and we subtract that from 1, that'll give us the odds of getting it once or twice. All right, so we're doing that kind of reverse thing that we did before. If we subtract away 0, it leaves the 1 and the 2 that we're actually interested in. All right. The other way we could have done this is we could have found the probability of 1 and then added it to the probability of 2. Either way will work. But again, this you can just go to your calculator and you can say, all right, 1 minus, and we're going to go to the distributions, binomial PDF. There were 2 trials. The chances of getting the true mean were 90%. And we want to know what are the odds of never getting it. All right. And that'll give us 0.99. All right. So again, this isn't a question that you're actually going to see on the quiz coming up, but it does just kind of show you how you can sort of tie back to stuff that we did earlier. All right, and you're probably thinking, if it's not going to be on the quiz, why did you waste our time with it? Sorry, it's just who I am. All right. The level of dissolved oxygen in a river is an important indicator of the water's ability to support aquatic life. You collect water samples at 15 randomly chosen locations along a stream and measure the dissolved oxygen. The mean value is 4.77 with a standard error or deviation of 0.44. Construct and interpret a 95% confidence interval to estimate the mean dissolved oxygen level in this stream. All right, so anytime we're actually making a confidence interval, we're just going to go to our calculator. We're going to go to stat. We're going to go to tests. And again, the two that we're choosing between are t interval and one prop z interval. We're never using this straight z interval, all right? So never pick that one. The question is, are we using t or one prop? Again, you just have to kind of look to the problem, all right? There's no proportions in this problem. They're giving you a mean and a standard deviation, so that means we're going to have to go to the t interval. All right, we don't have data. We have the stats that they gave us. So for this one, it said the mean was 4.77. It said the standard deviation was 0.44. It told us that we took 15 samples, and we're looking for a 95% confidence level. All right, so we've got all our numbers in there. We hit enter, and that's going to give our interval from 4.5263. So 4.5263 all the way up to 5.0137. And again, we used the t interval for this question. All right. So the confidence interval ones are a lot of times the easiest questions because you're really just plugging things into the calculator, and as long as you plug them in correctly, you're good to go. All right, moving on. All right, political parties rely heavily upon polling to measure their support in the electorate. In a country with 4 major political parties, a poll is conducted, and the Coffee Party is supported by 435 of 1,183 randomly selected voters who are polled. Construct and interpret a 98% confidence interval to estimate the proportion of voters who support the Coffee Party. All right, so again, this is just a calculator question. They're not giving me a mean. They're not giving me a standard deviation. So that means when I go to my stat tests, I'm going to be doing the one prop z interval. All right, x is the number of successes, which in this case is 435. N is the sample size, which in this case is 1183. And then they said they want a 98% confidence interval, so we'll type in that. And then you should get 0.3351 all the way up to 0.40032. Or another way of looking at that is the true proportion is somewhere between 33.5% and about 40%. And again, for this one, we used one prop z interval. Okay. All right, what critical value T star would you use for a 75% confidence interval with a sample size of 33? All right, so a couple of things here. If the sample size is 33, that tells you that the degrees of freedom are 32 or is 32. And then if we're doing a 75% confidence interval, that means there's 25% left over, but that 25% gets split between the left and the right. So that's going to be 12.5% or 1 to 5. So when we go to our calculator and we do inverse t, we're going to be doing inverse t with an area of 0.125 and 32 degrees of freedom. And again, inverse t is right next to inverse norm. It's in the distribution menu. There's inverse t. The area is 0.125. The degrees of freedom is 32. And that works out to be a critical value of, even though the calculator says negative, we always just use the positive, 1.17. All right. Next, a national opinion poll found that 44% of all American adults agree that we should stop teaching English and history to allow more time for math and science. How large of an SRS is required to obtain a margin of error of 3% in a 99% confidence interval? All right, so again, this is just that how large of a sample do we need question. Now, this one, they're not giving us a standard deviation, they're giving us a proportion, so that's the formula we're going to be using. So it's the ME equals Z star times the square root of PQ over N. Now, when the problem doesn't give you any information, you just use 0.5 and 0.5 for P and Q. But in this case, it gives us some information, so that's what we'll use for this question. So the margin of error, they say it can't be larger than 3%, so that's going to be 0.03. Z star we get by doing inverse norm. And again, if they want 99% confidence, that means there's 1% left over, and that gets split between the left and the right. So we do inverse norm of 0.5%. And then up here we have our 0.44 times our 0.56, because P and Q always have to add up to 1, and we're dividing by the square root of N. All right, so the first thing you would do on a question like this is just go to your calculator, do your inverse norm of 0.005, and get the value 2.58, because again, we ignore the negative. So we get 0.03 equals 2.58 times the square root of 0.44 times 0.56 over the square root of N. All right, and then it's just a matter of going through the algebra. So you're going to multiply both sides by square root of N and get 0.03 square root of N equals 2.58 times the square root of 0.44 times 0.56. And again, you could do this multiplication out. I just do it all at once in the calculator so I don't have to worry about rounding. Divide by 0.03, divide by 0.03, and then we're going to end up with the square root of N equals 2.58 times 0.44 times 0.56 over 0.03, and then we're just going to square both sides. So this is the point where I just usually put it all in the calculator, and I say 2.58 times the square root of 0.44 times 0.56, and then I'll hit enter, and then I'll divide that by 0.03, and then I'll square that at the very end, and I get 1822.37, n equals 1822.37. But again, we always round up with these questions, so the final answer would be 1823. All right, so again, it's just knowing the formula, plugging it in, and then just being careful with the algebra. All right. Which of the following curves has the highest probability? Think about the shapes of the curves. Randomly selecting a value greater than 3 from a standard normal distribution, randomly selecting a value greater than 3 from a t-distribution with 4 degrees of freedom, randomly selecting a value greater than 3 from a t-distribution with 20 degrees of freedom, randomly selecting a value greater than 4 from a standard normal distribution, or randomly selecting a value less than, that's actually supposed to say -5 there, so less than -5 from a t-distribution with 20 degrees of freedom. All right, so the key to this is to remember that you have your normal distribution, which looks like this, and then we have our t-distributions, which have fatter tails and lower peaks. And the fewer degrees of freedom, the fatter the tails. So if we randomly select a value greater than 3 from the standard normal distribution, all right, that might be like this part of the curve down here. All right. If we randomly select a value greater than 3 from a t-distribution, all right, that's going to be all of this area up here, which is going to be larger because the tails are fatter. Now, if we're looking at A, B, and C, they all say a value greater than 3. It's going to be the one with the fewest degrees of freedom, all right? Because the fewer the degrees of freedom, the fatter the tails, which means you have more area to the right of that 3 there. So that would be this choice right here. All right. Now, why is it not D and E? Well, it's not D because 4 is further out on the curve than 3, so that's going to be a lot less. And then the same thing for E. -5 is way out on the left side of the curve, and remember the curves are symmetric, so like we're way out here, so that's going to be even less area. So the one that's going to have the most area is the one that has the fewest degrees of freedom, but it's, you know, it's like at the same point as one of these other ones. All right, what is the Z star for a 93% confidence interval? All right, so again, this would just be an inverse norm question. 93% confidence means there's 7% left over, but that 7% has to get split between the left and the right, so that gives us 3.5%. And then this is just going to the calculator, inverse norm of 0.035, pasting it in there, and getting 1.81, because again, we ignore the decimal. All right, 1.81. And then last but not least, suppose the poll in the previous question was conducted by email and those conducting the survey are concerned about the possibility of undercoverage since some people do not use email or have filters that block mass emails. Which of the following is the best way for them to correct for this source of bias? All right, throw out the sample and start over again with a better sampling method. Use a higher confidence level. Use a lower confidence level. Use a t-interval instead of a z-interval. Take a larger sample. All right, so with this question, I'm going to kind of go back on a saying, which is garbage in, garbage out. If you don't start with good data, you're not going to get a good result, all right? And we can't fix that by increasing the confidence level or lowering the confidence level or doing T versus Z or taking a larger sample. If there's bias in your sample, you're out of luck. There's not a lot you can do. So it might not be the most intuitive answer because you're like, wait, it can't be that simple. But it is just, we would throw out the sample and start over. All right, you need to have good data, and without good data, none of this really matters. All right, so again, that was just a few review questions to help you get ready for the quiz. If you have any questions, make sure you're reaching out to me. I'm happy to answer them. I'm happy to work with you, but you gotta reach out. So with that, I'm going to sign off. Good luck and have a great day.